Today on Capecchi's Corner, we're going to continue with trigonometry and we're going to look at the sine and cosine ratios. In the last lesson, we looked at tangent. We're going to look at sine and cosine, and we have the phrase so, ka, toa, and that helps us remember the ratios. So the sine of E, we're going to use our diagram down here. The sine of E is the leg opposite E over the hypotenuse. That's how we get so. It's the S for sine, O for opposite, H for hypotenuse. So when I look at that ratio at E, my leg opposite of E is 7, and my hypotenuse is 25. So that's my first ratio. If I look at cosine of E, again, that's the CAH, C for cosine, A for adjacent, and H for hypotenuse. So the cosine of E, the leg adjacent to E is 24, and the hypotenuse is 25. And our last trig ratio is tangent of E, that's TOA. T for tangent, O for opposite, A for adjacent. So the leg opposite of E is 7, the leg adjacent to E is 24, so there's my tangent ratio. My directions ask us to find the value of each variable round to the nearest tenth. So now that I have a diagram, now remember I can only use trig ratios in right triangles, so I have to figure out which trigonometry ratio I'm going to use, sine, cosine, or tangent. In number 1, I have 67 degrees is marked, and I have my leg that's opposite, and I also have my hypotenuse, so that's going to be sine. So I have the sine of 67. My leg opposite is x. My hypotenuse is 120. So I have 120 times the sine of 67 is equal to x. And when I put that into my calculator, I have x is equal to 110.5 rounded to the nearest tenth. In number 2, I'm giving measurements of my triangle, but I need my angle. So when looking at my angle N, I also have my opposite over my hypotenuse. So that's going to be sine of N is equal to 22 over 40. I'm going to put that in my calculator. I'm going to use that inverse sign key again that we used in the last lesson. And I have N is equal to 33.4 degrees. I have to remember to use that inverse key whenever I'm looking for the measurement of an angle, not the measurement of a side. In number 3, I need two variables. I need x and y. So let's look. I have given 56 degrees. So I know my 12 is my hypotenuse. I know my x, that's my opposite side, and I know y is my adjacent side. So I know I have to use a hypotenuse because that's the one value that I'm given. So in trying to find things, if I first want to try my find x, which is opposite, then I can use sine. So I have sine of 56 is equal to my opposite over my hypotenuse, that's x over 12. So I have x is equal to 12 times the sine of 56, and when I put that in my calculator, I have x is equal to 9.9. Now, even though I have the value for x now, 9.9, I could use a tangent of 56 because I now have opposite and I can find the adjacent. But to be a little bit more exact, I always stick with what I already know for sure. That 12 was given. It was not rounded. So I'm going to stick with that. So now I need my adjacent. So that's going to be cosine. So I have cosine of 56. My adjacent is y, and my hypotenuse is 12. So y is equal to 12 times the cosine of 56. And when I put that into my calculator and round, I have y has a value of 6.7. In our last example today, we have a triangle that's a little bit complex. So we're going to take a look before we kind of dive in. I do notice that I have isosceles. So this is 12 and this is 12. So I have an isosceles triangle that would make these base angles equal. I don't know if I need that, but I'll mark it. And I also know that when I do that, my two triangles are going to be congruent. So this big value of 16 that I have here, I know I can split that in half. So it's going to give me a value of 8 here and 8 here. So now I'm looking to find v and x. So I need to decide how I want to do that. If I first look at v, I realize that I have a hypotenuse here and I have opposite leg there, so that's my sine. So I'm going to say sine of v is equal to 8 over 12. I'll use my inverse key, that sine, that -1 key on my calculator to find that. When I put that in my calculator, I realize that v has a measurement of 42 degrees. So if I know this angle right here is 42 degrees, because my triangles are congruent, I also know that this angle is 42 degrees. So in trying to find x, I realize that I have the leg that's adjacent to that 42, and I also have my hypotenuse. So if I have the cosine of 42 is equal to x over 12, so I can say x is equal to 12 times the cosine of 42. I put that in my calculator. I know x has a value of 9.